Yo, what's up, everybody? Welcome back. Today we are working on embedding a terminal emulator in my debugger application. So, context is we're running a debugger because we think they're kind of fun. It's kind of like a fun little technical exercise. Setting breakpoints and stuff is not as trivial as you would think. You have to like modify a running binary to replace some instructions with other instructions that trigger traps and then like replace them and stuff like that. We've been working on that as well as like parsing the dwarf info to try to figure out like what variables are there and like where are we and stuff like that. And so we've kind of got to the point now where we have like the world's most rudimentary GUI, right? We have a window here and it says we have stopped here. And if I press continue, the line number changes and we press continue and line number changes again. And we can see that like as that's happening, we see some like maybe semi-interesting information where like we can see, oh, here are the local variables in that function that we're at. I press that a few times and I get finished. Great. What I wanted to explore today was if we wanted to show this output in a window, it's actually not really that simple because like most applications kind of assume that they have some sort of like capabilities when they're running the terminal, right? In this application alone, like we colored some of the variables so that we could have some sort of like fancy coloring for a thumbnail that I took like a week ago, right? And so this is done if we look at our debuggy. This is done with some, sorry, dsphero. This is done here. It's done somewhere. Somebody, somewhere. Sorry, I'm trying to find it. Is it in GUI at SIG now? Did it move? Oh, it's in print locals. Sorry. Just give me a sec. Give me 1 sec. We'll get there. So this is done by typing escape x1b open brace 34m followed by a word. That changes it to blue. And then we do escape x1b 35m. That changes it to purple. And these are called ANSI escape codes. ANSI escape codes. And these are like a way of basically you like inline some data, and that is like a signal to the controlling, like the displaying console that it can do some stuff. And there's like all sorts of shit you can do with those. You can do things like clear the screen. You can do things like move the cursor 10 arrows to the right. You can be like clear this line. There's all sorts of capabilities that like might be used in a terminal application. And so we have to handle that if we want to show our application somehow. I will say that we have done part of this before. If we look at our YouTube, and there is a previous playlist here on writing a terminal emulator. So we've kind of explored this concept before. And it turns out that there's just like a lot of boring stuff to do in there, right? So I don't want to go through and really re-implement all of the ANSI parsing and stuff because it's mostly just like read, spec, do. And I think that like that's not really interesting, right? Like I think that people, I would, when I watch my own videos back because I'm a narcissistic piece of shit, when I watch them back, I'm looking for like, maybe like interesting concepts, right? And if you're taking like this big spec of things and you're just like implementing them, it's not really that interesting after the first few. It's maybe interesting for the first few to figure out like what types of things might be in a specification. But once you've done that, then it's just like, and you're just in like copy paste mode, it's not that fun anymore. So we're gonna dodge that and we're gonna try looking at this library, libvterm. This is what NeoVim uses. If I go into NeoVim and I type terminal, I've actually never done this before until I was looking at these libraries. But if I go in here and I type top, like the way top works is it is like doing all of these ANSI codes to like move the cursor to the top left of the screen. If I like resize the screen, never mind. I was gonna say it's supposed to adapt to that, but it looks like that's not the case in Vim. How the fuck do I get out? Let me out. Oh, here we go. There we go. Okay. So it should be able to do things like respond to window size reload and stuff. I don't know if maybe NeoVim hasn't looked that up or it's not a feature of this library, but we'll see. Anyway, so I want to try this library. It kind of looks like it handles all of the ANSI parsing for us. I think we actually unpacked this library yesterday, just like while I was looking for something to talk about. We did. And let's do this and look at vterm.h. So this is completely GUI agnostic as well as like backend agnostic. So really this is just like a way for you to push bytes into a thing and get out the current canvas state. right? So here you say, I had some input and please put this in here. And then when he says, okay, yeah, you've given me some input, I will give you back some output, it calls you here. I think. All I've done is read like a little bit of this header. So I'm kind of making like very large guesses based off that. But we'll see. So the plan of action is like spawn a child process in somewhere where we can like try this, like in a pseudo terminal. Then I want to like try to use libvterm in any way, shape, or form. Then I want to try to like display a canvas in QML because that's where it's going to go. And then after we've done like kind of like those 3 mini side quests, then we can do like the real thing of trying to make it work all together. So that's the plan. That's the plan, and let's get at it. So we are leveraging a little bit of knowledge from our terminal emulator project. And we know that, sorry, just give me 1 second. Let me think about how I want to structure this. I think we want to structure this as maybe we'll start in like a playground for a completely new thing. I think that'll be easier to implement initially. Let's just kind of throw a smiley face commit on whatever the fuck we were doing before, and let's work in a new playground. So, what was I saying? We're leveraging some previous information. And we know that there's this command fork pty. Pty fork. Fork pty, maybe not man2 meets man3. Man3 fork pty, sorry. And this basically says, ask the kernel to create a new terminal device for us, because kind of like the kernel is emulating, when you like type into your terminal emulator, it's kind of like pretending that you're talking to like this like old school like separate console, right? So like back in the day, you had like your little like computer monitor over here. He was really fat because it was old and a CRT, and he had like a keyboard like attached to him, right? And like, you know, you would have like your computer over here, and like he's got like a wire that goes to this thing. And so when I say create a new terminal emulator, Linux is kind of being like, here's a file that you can pretend you're talking to this guy on, right? And then your terminal emulator, right, with your like your little terminal emulator, which has a little cursor and stuff, he's kind of like got the other end of this wire instead of a virtual guy having that, or having like a physical guy having that, and he just kind of like implements all of the same things over this wire. So we have to like ask the kernel to make this wire for us, which is kind of funny. And then the kernel will like log into a user session in that environment. It kind of has like log user, I don't really know exactly what's going on, I can't really remember, but there's like some sort of like user management stuff going on there as well. But then once you're in there, then he will basically return like a file descriptor to like the source process, the master, I think they call it, and you can use that file descriptor to basically read and write to this guy. So by reading from him, it's like somebody was like typing on this thing, right? And by writing to him, it's like we were like piping data over. And I think the way it works is that when we write stuff, we write to this file descriptor, and then it sends us like the characters we typed back. It's almost like we took like this keyboard and moved it over here. It's my recollection. I could be wrong. So I think probably what I want to do is I just want to make like a new playground to work with this thing in. So let's do nvim source like terminal test zig. And let's do like a pub function main. All right. And what's he going to do? He's going to call fork pty. So presumably, Zig has a lot of these things built in for us. So does he have this one? Stud POSIX fork pty. Oh, he has fork stud OS Linux fork pty. No. I'm going to be a little lazy here. And I'm just going to use, oops, man3 fork pty. I think I'm just going to use the libc version because I don't really want to deal with this. Unless they have open pty, they might have open pty in here. POSIX open pty. OS Linux open. Yeah, okay. We're just going to use libc. So can we, where does this come from? Include pty.h. So we'll do const pty is equal to c import, and we'll c include pty.h, right? And then we should be able to be like fork pty, and this is going to give us a file descriptor output, I believe. Man fork pty. So it's a, sorry, this is the file descriptor name, and then these can be null if I remember. This is like kind of initial parameters that we don't really care about, probably at this point in time. And then, kind of funny, they have a name field here that is like the output name of the file that's created for the file descriptor, except nobody knows how much space should be reserved for a name, so calling openpty or forkpty with a non-null name may not be secure. That's very funny to me. That's very funny. So we should actually just be like null, null, null here. And then we say var fd is a cint equals 0. And we're chilling there. And then this guy, I believe, is like fork in that he will return one thing to the child and one thing to the parent. So how do we tell if we are in which one? Let's see. Create a new process. A file descriptor referring to the master side of the terminal is returned to master if name is not null. What about like return value? Here we go. Negative ones return on failure. The parent process gets the process ID of the child, and the child process gets 0. So here we should be like if PID equals 0, we're in our parent, right? But in here, I guess maybe we will just kind of read the file descriptor. May or may not be secure. Who fucking knows? Yeah, it's a really good point. I like the idea that it's like maybe it is secure. Who knows? It's unknowable. So PID is equals 0. We probably just want to like exec our like zig out bin debuggy probably. Did we call exec ve in our other example already? We do. So we just called him with null null. All right. And then this is probably failable, right? I don't remember. We'll see. Otherwise, we probably, in this case, I mean, if everything here works correctly, I think that this will spawn a terminal. Debuggy, we will see no output, and then it should just close, I think. I don't really know. But, you know, maybe. He's mad because POSIX has no member exec VE, so why did autocomplete then? Oh, it's V's with a Z for null terminated. Z for null. And he's actually mad because what do we do in the other version? Where was it? Sphero. Debugger. Oh, it's null in an array, right? Because it's there are arrays that are null terminated. So here we have to pass in an array whose only element is null. Of course. Error set is ignored, so we try here. And then, oh right, this try doesn't work because I don't know why. This is kind of like a weird bug that we encountered before, but it just like can't really figure out the fucking error for some reason. So we'll just do it this way. Okay, so now we see no output, which is kind of good, right? Because if we did this, like a normal fork instead, we would see that. I guess we don't know that we don't see that. I guess we can prove something now by reading from the file descriptor we got back here. So can we do like POSIX read? Is this allowed? Nice. So we can read from this file descriptor. Not sure if it's a bug, but exec.ve returns an error instead of an error union. Is there a difference there? No, this returns an error union. Am I crazy? But maybe I don't understand what you mean. Maybe I don't understand. Anyways, so let's read from this descriptor into some buffer. Oh, I see what you're saying. It's an error set, not an error union, because it doesn't have the exclamation point. I see. So maybe that's just kind of like intentional. Because it can't return non-error. Ah. So the try is not valid because it would always fail or something. Interesting. I didn't realize that. Okay, so let's, while true, try to read some stuff from this pipe. And what we should see is we should see the output of our application, debuggy, just kind of show up in this buffer. So if we do this, and how does this work again? POSIX read. Surely this is like a tribal thing and a buffer, right? So we try this, and then we have the size is this, and then we stood debug print from buff 0 to size, and we just kind of do this while it's true. I guess probably want to do like if size equals 0, do something special here. I don't know, we'll see. We'll kind of run it as is and we'll see what happens. So he's mad because he needs to say that we're printing a string. We probably could have just used stood outright, but you know, fuck it. And he's mad because expected a tuple or struct argument. That's a good point. I was writing C at some point. But we do see the output of our program, which is huge for us. Huge for us. So that means that we kind of understand how this is hooked up correctly, right? We have output from program writes the thing, we read from other side, great. So that's simple. I think the next step here is to try to feed this input into libvterm somehow, which shouldn't give us anything too interesting. Maybe what we'll do first here is we will make sure that we print out some colored information in here. We'll make our hello world red with escape x1b open brace, I think it's 30m or 31m, I can't remember. And then we clear it with 0x1b open brace m. M is like some identifier for like coloring and formatting info. Escape x1b is like an ANSI escape code with this open brace, and then this 31 is a parameter, if I remember correctly. So if we zig build and run zig out bin debuggy, now hello world is red, which means that we should get some form of interesting information out of libvterm when we use it. That's what I'm hoping, at least. Okay, so I guess what makes sense here is we hook up our little test to the build system, and I think that we can pull in libvterm as a dependency like this. Maybe this isn't how we want to do it. Yeah, it is. This is how I want to do it for now. So we're going to pull out the source code for libvterm by hitting copy link here. I probably should have copied with outside tracking, because I don't like it when they track me. And we're at URL is equal to this. Side note, I was looking at the build zigs on. Is this just like copy pasted into zig as source code? Is that why it looks like this? So there's like some structure that this is supposed to be matching, and that you open it with a dot thing here because it's just like inlined in the zig source. If so, that's very funny and reasonable, but it's just like kind of like a funny little, almost like a hack. He doesn't like this because he doesn't know how to handle this targuz, which kind of sucks. Kind of sucks. It just means that I can't pull this easily with the zig build system, I guess. So what's the workaround for this? I guess we just include the source code for now. So we'll make dir vendor, I think is what people call this. You vendor dependencies, and then make dir lib vterm. And we will curl-o this, tar xf lib vterm, and then we will remove this and yoink this, paste it here, delete this, and maybe we'll leave the version number on there. Fuck it. Zon is a strict subset of the zig syntax. Zig build zig zon is literally just parse of the zig parser. Also, what happened? Why can't you? Oh, fucking headers. I hit the web. Why do people not false headers? Yeah, sorry. I do think that the zig like dependency pulling is a little bit too fragile. Like, although it is fuck them to some extent, like there is some sort of like, it falls over, I think, relatively frequently for my use case. I assume that you guys probably just implemented it as like we're pulling tarballs from GitHub, and so like, what do we have to do to make that work? But I think there's a little bit of work that needs to be done there, probably. Looking at the code in here, I think it's usually I would be like, I'm just going to use their build system, even though people tell me not to. But in this case, the build is like very, very simple, which is nice. I guess, well, maybe not that simple. It looks like they have some generated files in here. Find wide characters. It looks like they're maybe just kind of, yeah, what's going on here? Encoding table. This comes from source encoding table. Is table generated somewhere? Source encoding. No, there's only include files. So anything that's generated in include file does not need to be done. So we don't need to worry about these, probably. Probably. We'll see though. We'll see. I guess let's try just typing make here. Can we like git add dot, git commit dash m import libvterm, and then if we make in here, we can see what happens. So libtool, he's mad that there's no libtool, so it looks like he's doing something. Where does libtool come from? I kind of assume that we can just pull in all the .c files eventually, but I do want to just run this build once the normal way to kind of see what it does. And then once we determine that it's doing something reasonable, then we can just kind of do what we want to do. So there's some .lo files, or he generated some .sos. In here, he generated some .los, which I don't think are very interesting to us. What is a .lo? libtool. Libs vterm.o. So sure, it's like some way of tracking .o files. Maybe. So yeah, he just did a bunch of .os, some .sos. No, it doesn't look like we have much like generated code in here. So let's just do this. And yeah, let's just try. Oh, fullwidth.inc, was this here before? No, it must be. It must not have been, or it must have been. So probably the tarball is shipped with all of the like generated files already made. So I think we're chilling. Let's just get into our build zig and just fucking slap some .os into our dependencies. So I guess we need a executable for our little test bed. So we'll add an executable that is, what was it called? Terminal test. Terminal test, boom, boom, boom. And here we are going to say that we are going to link libc for sure because we had a C library fork pty. I guess we need to install this thing for it to be part of the build. And then we are going to, I guess, try to build libvterm. So can we be like a source vendor libvterm source? I think we just do find .-iname star.c, and we just kind of slap these in here. I'm pretty sure this is it, but we'll find out. So here we're gonna do like, these are all gonna be part of files. So I guess we quote all of these, right? Like this, and then we add commas in between them, and then we just do terminal test add C source files. We can do this in like a nicer way later, but this is fine for now. And then I believe that the C source files thing has a like files structure, which is going to look like this. And then it also has like a root, which is going to be b path vendor libvterm 0. something 0.3.3 source. And this is certainly going to fall over in some way, but you know, we'll kind of tackle that when we need to, which is going to be now. He's mad because Failed to delete. Whoa, vterm internal. Oh, god damn it. Why is stuff failing to delete? Is it this like double build again? No, I don't know. So he needs some include paths, certainly. So where's vterm internal? It's in the source folder, and then we probably also need the include folder. So let's do terminal test, add include path of bpath vendor libvterm 033 include and source. And it looks like that succeeded, which is pretty chill for us, which means that now we should be able to go into our terminal test and be like c include libvterm or vterm.h. And we should just be able to start running it. All right, so let's see what's in there. If I hit like jump to definition on this, he doesn't know, that's fine. That's fine. I think it's because we turned off auto compilation intentionally. Also fine. So I didn't really see any like docs or anything for this thing, but it also seems like the header is pretty straightforward. It seems like we should start by making this thing somehow, which I think I saw vterm new. We could hook up a Zig allocator. I'm not gonna fucking do that, you know, but we could if we wanted to. And maybe we will do that in the future, but I'm not gonna do that right now because fuck that noise. So it looks like we should just be able to call like vterm new. So let's kind of like maybe if true return up here. When is fair for? Are you gonna make some Zig courses on YouTube or something so I can give them all my money? I mean, I don't think. Okay, I mean, I should just ignore this, but also, one, I don't really know Zig, right? Like, let's be honest. Like, I've been running Zig for a couple months. Two, I'm not here to like teach you, right? I'm kind of like here to like entertain myself, and like if that happens to provide value to you, that's like super cool. But like, what I am not trying to be a teacher. I'm like at the very, very most just trying to show a way of working that happens to work for me. But in reality, that's probably not like, I don't know how valuable that is even either, right? Like I just want to be like very clear because like I see people like asking me to like sometimes I get like irritated by YouTube comments. They're like, "Can you do this topic next?" And I'm like, "Bitch, I'm not here. Like I'm not here to teach you. I'm just here to have some fun." So I will show and inspire, if you will. Well, show. Anyways, I just thought I'd address that head on. So never. The answer is never. I will never make you a Zig course. And you shouldn't want me to as well, right? Like I just want like if I were to write a Zig course and you were to learn from it, it would be bad because I don't really know Zig very well. Anyways, okay, what am I doing? I'm trying to use libvterm, so surely we should be able to like vterm new. And we have rows and columns. I think was it row column or column row? Vterm new. It was row call. So rows we want like maybe 60 by 80 or something. Who fucking knows? We'll figure it out later. And this returns a vterm, which means later we need a vterm free or dealloc. I can't remember what it was. Vterm free. So let's just start there. And if that compiles and runs, we're fucking chilling. So we can call zig out bin terminal test, but we're in the wrong folder, so that won't work. Git clone, git at github.com, zig zig, cd zig libstud is the best Zig course. I actually do agree with that. The standard library of Zig is like, it's nice where you look at like the standard library of C++ and you're just like, how the fuck am I ever supposed to write that? Ever. And the answer is you won't. Right? But you might be able to write something that's in the standard library of Zig because it's just like very understandable. Okay. So I believe that if we want to like hook this up, I think that all we have to do is just like feed this thing with vterm input right. I don't actually know this. I guess we probably have to set the output callbacks first. So let's start there. So we'll just kind of copy paste these functions so I don't have to keep keep swapping back and forth between files. What file we're in? Terminal test.zig. So here I'm assuming that we want to do like, maybe we won't if true return here. And just instead of like writing this stuff out, we will throw a vterm input right here. I don't know what input right gives us back. Probably the size of stuff it wrote. I assume vterm input right. We can look at its implementation. Size t written looks very promising. So I think we can assume that that is the case. So I guess in theory this could be lower. For now, because I don't want to deal with it, I don't really want to. Sure, we'll do it this way. We'll do it this way. We'll go while var vterm size equals 0, while vterm input right vterm size is less than size. We call this with the vterm. So this is vterm, the bytes, which is going to be buff pointer, and the size is going to be size vterm buff pointer plus vterm size, and the length is going to be size minus vterm size. So vterm size is going to be how much that we've written so far, and then this is going to be const ret. We're going to have vterm size plus equals ret, but only if this succeeds. So I presume that this can fail. So if ret is greater than or equal to 0, we do this. I guess this is only if it's greater than 0. Else return error vterm right. And then here we will say if vterm, the while loop breaks us out of this already. No, it is telescope. Whoever asked what is that, it's telescope. Oh, Ranger. Ranger and telescope are both things I use. I don't know which one you guys are talking about. I didn't make either. I did not make either. Okay. So let's just double check, I guess, that it can return error. I'm just kind of assuming. I guess size t is not s size t, so probably there is no less than 0 case. It looks like this is defined here. So what is returned from this guy? Jesus Christ, Jesus Christ, Jesus Christ. I'm seeing a lot of previously seen, I'm seeing a lot of familiar things in this block of code that are giving me flashbacks to the terminal emulator. But I think that there is just, we can just do, this seems probably fine. This seems probably fine. Okay. So then we need to set our output callbacks. So that looks like it's this function. So this takes in vterm and our function, which looks like it's defined as this. So we'll just make a little like pub function vterm output, and he takes in this stuff. So this is going to be a S is a multi-element U8 pointer. The len is a usize. And user data is a void star void in this language. And this returns void. Okay, and this needs to be externs or callconv C. Does this go after? Feels like it should go here. But it looks like maybe they want it before the return type. To say, hey, we're going to be passing this to C function, so please use the correct calling convention. And here we are just going to do a print, I guess. So what do I expect from here? I don't know. Maybe I expect the red to be pulled out. Right before we had red in our output from the ANSI escape codes, I kind of would think that vterm should strip that shit out. That's what I expect, but we'll see. I don't know if I'm supposed to put an ampersand in front of this or functions are pointers already by default. I also guess that this should be a question mark thing here, and then we will save this unused. Let's just see what happens if we do this. He doesn't build, of course, because expected this, found that. So we need C pointer and any opaque instead of void. Right. And this is C. He's still mad because expected type this thing, found that thing. So we have constituate. Still more errors. I wish that they showed up at the bottom, but we'll live. vterm size, it needs to be a usize. That is fair. And then what else? Buff pointer is not in there. That makes sense as well. So here we want to take just the address of buff. And I don't know if that plus is going to work out there, actually. You know what we can do? Is we can disable the build of our normal debugger, and that will prevent the Qt stuff from ever being built, and that will make this whole thing much easier to work with. Are you referring to Zig build prominent compilers? Maybe. It sounds like something I would be talking about. I'll take a look at that maybe in a minute. But instead, I'll just comment out the Qt build, which is fine by me. Can I just say that this is like a U8 pointer like this? Is this gonna work? I feel like it might. Oh, he needs it to be a multi-element U8 pointer probably for this to be a valid cast. There we go. Okay, so now there's an IO error here on POSIX read, which is probably reasonable. That probably means that the child process died. So can we be like catch break here? Probably. I mean, unless it says like E again. Now we're not seeing any output, which I was kind of hoping we would. I was kind of hoping that because I thought that by calling vterm input right, we would kind of end up in the output callback. I wonder if there's some sort of like vterm thread we're supposed to run. I think there was in vterm, there was like a bin folder. And can we just look at like an example in here? So here they do vterm new. They set parser callbacks, which are interesting. But then they call read, they write the thing. And where do they set like the output callbacks? Maybe that's kind of in here. No, maybe there is no output here. So let's see if there's another bin, vterm, bin, vterm control. I don't think that's what we want either. Yeah, that's not what we want. vterm, bin. So the only other option would be unterm. Okay, so he sets some screen callbacks here. Very interesting, which is different than output callbacks. Jumble of letters and numbers. Thanks for the prime, much appreciated. Okay. Okay, so what's going on here? So they're actually not setting output callbacks at all, which makes me think that I'm doing something wrong. But I also don't really know what unterm does. Maybe we could look at vterm. So we've seen some screen callbacks and some parser callbacks. Screen seems interesting. vterm.h. So what is a screen in here? Do they have like any words that they tell us about here? Screen layer. Okay, so we can get a screen and we can get some callbacks, which are these things. So here they're saying clear the screen, pop line, push line. Oh, okay, okay. So we're probably going to end up with push lines from the screen callbacks, right? We could imagine an abstraction where, like, you are supposed to model the screen yourself. You tell vterm the size, and you have like this canvas. And when you push a line, they're kind of saying like put a line at the bottom of your screen. Pop line means like get rid of the line at the top of your screen. Int calls is confusing to me. What would popping a line do that has to do with column number is very confusing to me. Can we look at maybe somebody's going to call SB pop line somewhere, right? So this is called in resize buffer. Okay. And what is, I forgot already what we were trying to look at. Wasn't it called pop line? SB, oh, SB pop line. So they have old columns passed in here. Oh, I see. So they're saying like, maybe it's like if you've resized your terminal, then you kind of want to know, say you had like a buffer of just like characters, the column width probably tells you how many of those characters to pop, right? One line is this many columns, is what they're trying to say here, which is fine. Okay, let's try using the screen. Let's just try it and see what happens. So they had, I guess we should have copy pasted that, or we'll go into vterm.h, and it was obtain screen and get callback. So we're just gonna gonna throw all this stuff in here for now, and we'll kind of see where this goes. So we'll say that the screen is this thing. Okay, and then we are going to set the callbacks. I guess this is a C thing. And I guess here we're going to have like const callbacks is a C vterm screen callbacks. And we will fill this in as needed. It looks like they, from that source code look, that it supports kind of being a, I don't remember how to say this, like nulled out, things can be null, that's okay. So we should be able to be like, we don't want pop line, we probably want push line, it's probably the only thing we care about at this exact point in time. So we'll call this push vterm push line. And this will go here. He returns an int, cint, I guess. And this is going to be call conv c. And this is going to be function. What did we call it? Vterm push line like this. All of this can probably go away, assuming that he's okay with that. He might make me say everything is null. Actually, I think that he will make me do that. So I'm going to start here, copy all this stuff in here, and try to figure out how to auto set this stuff. So we're going to be like, jump or delete till you find a star, put a dot at the end of the line or end of the word, jump to the right, delete everything, and then equals null. Seems reasonable to me. And then here we will do what we're doing here. Boom. So this is calls is a cint, cells is one of these things, and user data is any opaque. I guess when we're interacting with C, anything that's a star has a question mark in front of it. And then what are we going to do here? Cells, vterm screen cell. So this presumably is going to have a lot of interesting information associated with it. Right, so this has things like the colors and the characters. Max cars per cell. Interesting. I wonder what a cell is then. So this has a width. The width of the cell. The characters in the thing. Okay, so for now, if we just print If cells, can we call this cells opt so that we can do const cells is equal to cells opt or else return 0, I assume. Okay. Then we can just say for cells, cell, and each cell we were going to look at the character, we're going to print the characters from 0 to cell car size, was it? I can't remember. Width. I'm pretty sure that's what we can expect here. And we won't look at any of the attributes for now. We just want to see if this is right. So now we should be able to pass in the screen and the callbacks and null. All right, let's see what happens. vterm screen cell needs to be prefixed with C. I forgot to comment on whoever said thanks for, or when Sagamon said thanks for the prime, or escape W plus. That's a funny. I like it. That's a funny. He's mad because I can't. Whoa, what's going on here? C import. Opaque types have unknown size and therefore cannot be directly embedded in unions. That's true. So is that like a bug in the parsing here? Because screen cell atters bit fields. No! Why do they have to use bit fields? Okay. Fuck. Can we avoid this somehow? Oi, 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 oi. So, sorry, I'm just thinking. We could manually patch this. Yeah, I think probably the easiest thing to do is to manually patch the U30, this thing into like whatever size this is. What would translate CD with bit fields? I mean, we can see it right here. If we look at, we can see exactly what it does. What was it? String fragment. He sets it to an opaque struct because he doesn't have support for that, right? So I think that what we do here is we call translate C ourselves and then patch that part out. It would be nice to do that automatically, but I'm not going to bother with that right now. Instead, I'm just going to do it by hand. So we're going to do zig translate C vendor libvterm include vterm.h. Why doesn't that work? Why doesn't that work? Do I have to type LC here? Okay, I do, okay. So we can do this, and we can say, this goes to source vterm zig, and we are just gonna look at the size of that thing, which is in vterm.h, and this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, oh god, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, plus 4 is 16. Right? No, 18? 18. 18? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, 18. Which means that this thing is probably a U32 size. That would be my guess here. I guess we can test that with include vterm.h and int main int. We don't have to do anything here, and then we just say, can we like printf a, I don't know, size of vterm screen cell atters. Let me see, gcc -o test.c. with an include path of zig out bin, or no, libvterm, nope. Source, fuck, where am I? Vendor. And we need include stdio. Cool, so 4, and then I can assume a line of. Is that not allowed? C a line of? Thought that was a word that we could ask. Is it crazy to ask for a patch to support in the Zig build system? I know there's already an issue for it, and I think that it's just maybe not like trivial. So instead, we will do this. 4 and 4, yeah. So just U32. So we will just patch our lib vterm.zig, and we look for vterm string, and we'll just replace this with a was it string fragment? It was, right? I think so. We'll find out. So now instead of coming from C, we'll call this a C and call vterms equals to import vterm.zig. And we'll call this libvterm, I guess, so that we can use this here. And everywhere it says cu.vterm, we replace that with libvterm.vterm. And then we need one more on a type somewhere here. vterm screen cell attrs. Okay, we got another one. I think I just did the wrong type without thinking. I think I just did. Fuck. So is this one. Oh, string fragment was the same. It's okay, we just run the same test. He wanted vterm string. Oh, screen is string. This is 16 and 8. So we can replace this with like 2 U16s, I think. Oh no, 2 U64s. Should be how that works. So we should be able to struct U64, U64. Oh my god, he doesn't like that because extern unions cannot contain fields of type vterm string fab. Oh, maybe extern struct here? And then here we'll do like A and B. Okay. Cport has no vterm screen callbacks. Yes, it does. It's right here. Am I just stupid? Terminal test.zig. Oh, it's because it's in C. I knew that. I knew that. And cells is not an indexable range because this has to be a multi-element pointer. And then single element pointer cannot be cast in multi-element pointer. Fine. Can we just do C then? Parameter of this type is not allowed. Oh, because there's an optional now. The optional gets folded into the C pointer. Unbounded for loop. That's true for cells 0 to. How do I know how many cells there are? Is it just one? Is it just one? Maybe it is. Yeah, it must be. So it's just this cell. This is cell opt, I guess. I mean, we should just double check that. vterm.h callbacks push line. Oh, this does say cells. Maybe it's null terminated. Oh, this is pop line cells. Yeah, push line cells. Can we look again at SB push line? SB buffer. I think we'll assume that's one for now, and then we can always come back. Maybe we'll put a comment here. Are we sure it's only one? You know, we'll see though. So he's mad, expected this, found that. So he's expecting type const screen for return screen callbacks, and he found non-con. So do I just have to write var here? No, this is, oh, here we need to return 0. And if I just write var here, does that fix it? Oh, I'm passing callbacks not by reference, probably. Forgot to put a little bit of one of these on his head. Now he's mad at me trying to format a string as a U32. That probably makes sense here. Well, that's interesting. That's very interesting. Okay, let's go 0 to cell width and like let's take a look at those things. Because that's very surprising. What language is this? What the fuck? It is Zig. Zig, zig, zig. A legal instruction. That's also interesting. So he's saying at parser.c, state.c, very interesting. What's he bitching about? Okay, so where are we in here? We have an illegal instruction that he's trying to execute, supposedly. Where is the arrow on here? This is a long function. Oh, I think I saw it. I think I saw it. Here. The fuck is UD1? I mean, I guess that's probably the part of the problem, right? X86 UD1. Undefined instruction, yeah. So somehow this is just fucked. Very strange. Very, very strange. I think UD1 comes from sanitization. Ah. Okay, okay. So just theoretically, I guess we could be making a mistake in here somewhere. If we have because we're supposed to jump if they're not equal. So it's possible here that we've just made a mistake on this input right. Can we just kind of start here by writing the buffer directly with the size and see how that kind of plays out? And then we'll say std debug assert ret is equal to size, just for now. Just for now. Still a legal instruction. Interesting. Interesting. Is it possible that we like fucked up? I mean, libvterm new was returning a vterm, which was always fine before. So it shouldn't be that. It could be if we fucked up our like alignment thing with this like vterm screen cell attrs thing. If maybe the like our side thinks that something is not the same size as the other side did. However, we can check that by not setting our callbacks, right? If we don't set our callbacks, then nothing. That case shouldn't matter, which it doesn't. Okay, interesting. Interesting. So this is in here somehow. So he's trying to do some sort of encoding. Jesus Christ, what am I looking at? What am I looking at? So we can look at maybe p encoding enc decode. Okay. That's a good sign, I guess. Okay, vterm encoding is not set. So maybe we missed an important step here. So in our example, they set screen callbacks. Is callbacks supposed to have an encoding on there maybe, and we just didn't set it? No, we didn't even set our callbacks. Oh, set UTF-8? They do? We could try doing that, see if that changes it. I guess also, probably, all of this stuff should only happen in the parent branch. Which maybe, I assume that that doesn't have any real effect, but it could. Could, you never know. This needs to be 1, I guess. We are still in the bad state. Okay. Very interesting. Encoding enc. So this is null pointer. I guess we try to figure out where that comes from. What was it? Is state.c? Yeah, it's here, right? So here, this comes from state.encoding. Okay. Jesus. So what was our encoding enc, right? This is null, which means that we got a bad encoding in this thing here. Which means that we should look at we should look at all of these options. I think. So we should look at like this. Okay. This. Okay. This one's good. So most of these are just fat garbage, right? And why? State G single set. I guess we probably want we'll list from like 280 a little bit just to get them all. Okay. So P state G single set. False. Which means we're like probably looking at bytes eaten and 0x80 is 0. So this is probably true. So we're probably in this one. But this is also 0. Okay. So what's going on there? What is going on there? It's either we have some like hard invalid shit in here, or there's a bug, or we've compiled it wrong. All of these are possible. All of these things are possible. Could it be UB and libvterm? Check F no sanitize equal define. I mean, when we look at this though, it's like pretty clearly just null dereferencing, right? Like it's gotten a encoding that is not valid from here. So I think it's more likely that like something is wrong. vterm state reset looks like something here on escape. It looks like they kind of update the encoding function for these things depending on what they've seen before. Do they do, so they do a screen reset here, which maybe is important. Maybe that's like an initializer thing that has to happen. Although this is vterm state reset. Who calls this? I wouldn't be surprised if this comes from screen. He does. So it's possible that we just missed an important piece of information here that we are supposed to call vterm screen reset off rip. That seems very likely to me. So let's just do that. And I think they called it with 1. If I remember correctly. Yeah, they did call with 1. Okay, let's just see if that fixes it. There we go. Okay, so we are still not seeing anything interesting happen. Oh, but it's also because we didn't register our callbacks. So I think that's reasonable that we don't see anything interesting happening. We still don't see anything interesting happening though. Can we like at least log? Hi mom. Like, is this happening? No. But we can look at the example again. So they set callbacks to pushline and resize. So that actually doesn't seem crazy. Oh, but he's returning 1 on success, maybe on reset? What's his implementation of pushline look like? He is returning 1 instead of 0. So maybe like the assumption is that these are bools. This isn't getting called ever though, but we could try implementing resize and see if that changes anything. We could try it. Which is what? This thing. A function vterm resize is equal to a function that takes in these things. I don't really believe this is going to make a big difference, but maybe. Yeah, so still nothing. Still nothing. Is resize called? No. All right, so maybe I just don't know how to use vterm. I mean, I definitely don't know how to use vterm, but I kind of hoped I would be able to guess a little bit better than this. He does call dump row here. What does dump row do? He gets screen cell for each position in columns. So maybe pushline and popline are only for scrollback. I think we did see that somewhere in the docs. I can't remember where. So maybe we are actually just supposed to run the screen. Okay. Sure. So maybe we call get cars on this thing. For this rectangle, get text for this rectangle. Okay, can we just get text for the whole screen then? We could try that. We could, at the end of our function, terminal test, we could do vterm screen get text given our screen for the into our string. So var out buff is, I guess we can just use buff again. Right, like this, and then he has a rect that we need to look at. So what does this thing look like? Start row. Okay, so we're going to do like kind of like the whole screen. So it was a libvterm rect. And here we just have these, and the start row is 0. End row is, I think we had rows like 24, is that what we said? 80, 60. Start call we had 0, and end call we had 80. We try to get the screen for this rectangle, which returns a usize, which is probably the string length. We can probably print this as slen for buff from 0 to slen. Right? Found pointer, so he wants it by value. Sketchy, but probably fine. Oh, okay, so we printed some stuff. There we go. All right, all right, all right. We're getting somewhere. We're getting somewhere. So it looks like that push line and pop line is only for scroll back. Which it makes sense now that I think about it because they're also prefixed scroll back, so we probably don't need them. Probably don't need them. Okay, so that is interesting, and we can also see, we do see that the hello world has been stripped of its color info, which is really, it means that the libvterm is in fact doing something, right? He is in fact parsing the ANSI response codes correctly, which is a big win for us. Big win. Okay. So now what? Now what? I'm just thinking, I'm thinking. I would like to be able to, it would be nice to get the color info hooked up, right? But I think what would be a kind of like a more satisfying thing to do next would be to try to hook this up to our GUI. So I think I want to do something like, we're going to follow the same pattern we did yesterday for our QML GUI, where we have like a kind of like C bindings to some kind of like Q object thing. And our Q object will maybe just initially hold the state of the terminal emulator. That seems reasonable to me. So let's do something like, where are we? Can we do terminal.h, which is going to look very similar to app.h. Okay. He is just going to show, he has two responsibilities, right? One of them is to like push input from us to the terminal. We can ignore that for now. And then the other thing he has to do is like display the current data. So maybe we'll just say terminal emulator state here is going to be a Q object who has a Q string content. It's going to get content and notify content changed. And he's also going to have the width of the terminal emulator and the height. So height and height changed. Okay. So he initially is going to have like content is nothing. I guess we can kind of like default initialize him. And the width and height, I guess we'll just match it, but it doesn't really matter. We have 60 here, I think. Okay. Then we have to make our functions that were get content, get width, and get height. So we have a q string get content, and he locks the mutex. Okay. And then returns content. This is content changed, width changed, and height changed. Okay. Then we have getters for get content, get width, get height. And get height. All right. Now we need kind of like, fuck, I did it in the wrong the wrong file. Okay, here's what we do. GUI terminal.h is terminal h back. GUI.h or app.h goes to terminal.h, and then terminal h.back goes to GUI.h because this was the old one. I just changed the wrong one. Or app.h, sorry. There we go. Okay. Was it terminal.h? Okay. Then we have this guy set up, and then we had GUI.cpp. So we'll kind of do a similar thing here for GUI terminal cpp. And we have kind of like the same thing where we're going to have a terminal. I already forgot what we called it. Terminal.h. Terminal emulator state make GUI. He's going to have no callbacks for now, and he's going to create a terminal emulator state. Okay. I'm thinking. This is now terminal.h, probably. GUI.h is going to be like terminal GUI.h, I guess. I don't fucking know, man. Things got to go places. We make the GUI, and we have set width, or set size, we'll call it. Or maybe we'll just call set state, and we'll just do everything at once. That might be easier for us for now. So he's going to take in a content, and then the content len, and then he's going to take in the width and height as well. Like this, and he's going to be like state, set state, with all of this stuff. Content len, width, and height. Okay. When we run this thing, we're going to be like, could you make me a, I guess we'll leave the same thing here because we haven't experimented with changing this yet. And there's going to be a terminal main QML. We're so close. Okay. So that means we need a GUI main QML. Go to GUI terminal main QML. And for now, let's just print the content with the width and the height. So maybe we just kind of match the width and height to the expected. No, we can't because they're this is pixel space. So we'll just be like, let's just start with a text of the content. Set shift width equals 4, tab stop equals 4, expand tab, set file type equal QML JS. There we go. Okay. So this will be like text is my API.content, right? That's all we need, I think, for now. And then the last piece we're missing is like the C glue code here. So we need like GUI terminal GUI.h probably, which is going to be like look like What are we gonna have in here? Terminal CPP has these functions, and that's kind of it. So we have like if def C++, we do like an extern C block. And then we have to close that block. And then here we just kind of start going like, okay, so this guy gets a, we have to turn this thing into like C-like looking things. So we have like struct terminal emulator state. We get a pointer to that from make GUI. We can set the state on that thing with this function. And then we can have a run GUI that takes in the terminal emulator state as well. Like this, and this probably has to include terminal GUI.h, which it does. Cool. I think everything is in place now for us to be able to hook this up. So if we go into our Zig app, which was terminal test, we go in here and we say our C is a C include of terminal GUI.h, which won't compile yet. We need to go into our build Zig, and we have to kind of do a very similar thing to get to GUI source files here, but this is going to be like get terminal GUI source files. We are not going to do any resource compilation. Fuck that shit, because we found it was broken in Happy Hour. Really fun bug, by the way. If you want to check that out, check the Happy Hour archives. It was very fun. Resources we are not going to return, but we do still have to mock this thing. Generate the Qt C++ associated with the Q object that we made, which was in terminal.h, I think. And so this is GUI terminal.h. And then we also are looking at the terminal.cpp as well. Okay, so we get these files out of get terminal GUI source files. Given a build and a Qt install path, which we get from here. And we'll say const terminal GUI files equal this. We kind of do this down here, I guess, associated with terminal test. And we say for terminal GUI files, we add this to our build. So terminal test dot add C source file equal F. Boom. Bang, bang, boom. Surely this won't build. There's all sorts of problems with this. This needs to write try. This needs to write try. Now he's mad about terminal GUI not being found because probably in here we have to add an include path of GUI. Okay, expected identifier or thing in terminal GUI.h. I did forget to remove an extern C there, huh? And I did forget to add a semicolon. All right. Must use struct tag. Right, so here we forgot that in this language, you have to do this. In C++ you do not, but in C you do unless you type def. Size T, he's mad because probably need like include stdf, probably. Qt GUI not found in terminal CPP. Probably because we need to also add the include path of it's like a Qt install dir path include like this. And that means we probably need the link path too. Add library path which is in lib, and then we also need to link the libraries, which are Qt6 core, GUI, and QML. All right, baby. We're so close. This, I think, the path thing needs an allocator pass in. I don't really know why, but, you know, I'm not going to complain. I'm sure there's a good reason. All right, still mad because we forgot to link libc++ as well. There's so much stuff we gotta do. There's so much to do all the time. My life is so hard. I think this is like the least fun part of coding, but like you also like have to understand it. So like just get fucked. Why does he think it's C plus? He thinks it's in C, not C++. Coming from terminal mock H. Oh, because I'm an idiot. This has to be output to CPP for it to correctly identify. Oops. I was taking a header file and generating a new header file. No, no, no. Generate header file, take header file, generate CPP file, please. Much better. We're getting closer, I think. And now he's mad about terminal.h. Oh, did I just miss some stuff? Do these Q properties need... First of all, why is he talking about GUI handling here? Oh. Shut up. And this guy just takes in a Q object null pointer. So that's probably related. I don't know if that was all of the problems, but we will compile and let it tell us. So he's mad that there's width can't be returned here. To int to Q string, he doesn't like that. qcar, okay, sure. And he's just like listing all of the possible things he tried again. Dude, fucking C++, man. The compiler errors are just like, I tried 400 overloads. Would you like me to list them all for you, please? It's like, no, just you don't have to do that. You don't gotta do all that. We are still missing a GUI, some GUI handles kind of leaked around here. This is terminal. Where's this come? Terminal GUI.h is probably where this comes from. I should have named things better, but you know, we're just kind of fucking moving and grooving. Who fucking cares? Now he's mad at there's no set state. That's true. That's true. So how do we fix that? We make a set state. And this takes whatever the fuck our other set state function took, which is in terminal CPP. So we just kind of propagate these things onwards. But now, what do we do when we set the state? We probably do like lock guard. We certainly lock our mutex. And at the end of this, we certainly omit all of these things changed. Maybe we should do them all at once, but you know, whatever. Because this is going to trigger 3 updates of the QML tree, which is probably not necessary here. But you know, whatever. We could also be a little bit more tricky here, and only update the ones that need to be updated, but shut the fuck up, you know? So we learned yesterday that Q strings cannot be constructed from a string and length, but they can be constructed from a Q byte array, which can take in a string and length. So we'll call this array is content plus content len. Then we have content. This we have to be careful because we have name collision. So we'll call this new content. Like this. Okay, this is now our array like this, and this takes in new content, not old content. Sketchy, sketchy, sketchy. Width is equal to new width, and height is equal to new height. Wow, look at us go. Look at us go. He's mad at too few arguments to function call. That's true because in this language, the class argument is automatic unless you write static. There we go. We are chilling. So we should be able to now maybe go into our terminal test, and we'll just kind of do a stupid thing right now where we will launch the GUI at the end. So we should be able to be like terminal.h, nope, terminal GUI.h. Maybe I should name things better. Do you guys ever think that maybe we should name our functions good? Okay, so we're just gonna be like, yo, make me a GUI, please. Okay, and then we'll be like, yo, let's set some state on that GUI. So we have the buff len, the width, which we just had like 80 and 60. Okay. And then we are going to run the GUI. And hopefully everyone's happy. They're not though, because set state is not there, because that's true. This is c.setState with the GUI. And then we have to ignore the error here. Fix me, ignore error, question mark. Names that make sense are for wimps. Real devs mangle their own names. True. Okay, so what we should see here is we do see that the content of the terminal has now made it into our application, which is a big win for us, right? And now let's try to make this like monospace in some way, I guess. So we kind of displayed any canvas in QML. And I guess let's try to make it look more terminal emulator-y. Make it more terminal emulator-y. Okay, so the first thing is obviously monospace font, right? Can we go into terminal main QML and let's just start looking at like QML monospace font. What can we do here? Font family monospace. I mean, that guy just said he did that, but I kind of want just like QML set font is more what I want. Text. We just want this text thing to give us. Is there like family in here? Yeah, so font family, can we do monospace? That's definitely monospace. Big win for us. And then I do want the font size to be a little bigger. I think you can do like this. If we want to group these things together, if I remember correctly. So here we can do like size, point size is 16. Did that get bigger? No. He got mad because unable to assign int to qfont. Qvariant, maybe I'm wrong here. I thought you could do it this way. Am I stupid? Let's try this first. Oh yeah, that's fine. So it's just that the point size was wrong. Yeah, he doesn't like that for some reason. Why not? Font, point size. I'm actually confused. Comma? I'm pretty sure there's not supposed to be commas here, but maybe there are. No, expected token 15. Yeah, I don't think so. I'm pretty sure that it's not supposed to be like that. Because here the properties aren't like that. Maybe we can look up. Oh, here they have an example. Yeah, they do exactly what I did. You can also collect the font properties in one object. That's what I thought. Am I stupid? Font point size 16. Let's just try that first. So that works. But if I put point size in here, it doesn't work? All right, whatever. I don't know, man. You're saying comma, but like they don't put commas in here, but they do in features. So who fucking knows? Who fucking knows? But there we go. Okay, so that's great. And then I guess what we probably want to do next is we probably want to somehow add the color information uh, from the hello world back in. Right? That's probably the right call here. So let's figure out how to extract that information. So I guess it's going to be in vterm.h. They have these like cells in here, right? And I wonder if vterms, the fact that these things are like uint32 characters, I wonder if they're like masked in there. No, because they're kind of saying that we're setting attributes for the whole cell. So I wonder if we can get like get color information. So there's like these vterm color things. There's vterm color is index. Where does this come from? So we can say, give me a color. Oh, wait, no. Okay, where am I supposed to use this? On this vterm color thing. So where do I like get one of these from? It must be from get characters. Maybe not. Get attributes extent. Get cell from a position. Okay. vterm screen get cell. There are examples of that in here. And are there examples of vterm screen get cars? I'm kind of interested in that as well. So he gets the characters and he prints for each character here. He just prints the bottom half of it. Okay. So why are the cars U32? There must be a reason for that, and I wouldn't be shocked if they're like embedding information in them. But who knows? Cell chars 0 get cell. Okay, okay. So, I mean, getting the cell seems like it's probably the thing that makes most sense to me right now. Because these cells have, like, colors associated with them. Right? So we can probably leverage that in some way, shape, or form. What we could do is we could use QML's rich text. Sorry, I'm just reading a comment. You had a comment after font family before point size when it was a font. Maybe that's why. Sometimes I did. I tried with both on and off, so I don't think that was it. And what are in these attributes? Bold, underline, right. So this is like display information as well. Okay. So I guess maybe in like our Zig side of things, maybe instead of calling get text, do we just get the cell for each position? So like for 0 to 80, call. For 0 to 60, row. I guess we should probably fucking name these, huh? We'll say like const num rows is equal to, I actually want it to be smaller. We'll do 24 by 80. And we'll just look for 60, and this becomes num rows. And we look for 80, and this turns into num calls. Okay. And then in here, we're going to do something like what? What are we going to do? We're going to get vterm screen get cell at this pause. So we need to pass in. We have var cell is a pointer to a vterm cell. We pass that into cell here, and then we also have to pass in the position. So it was a libvterm position, and this was row is equal to row, call is equal to call. This doesn't return an slen, this returns a cint, so we can probably assume less than 0, but maybe we check. He returns 1, just kind of like unconditionally. So I guess that the kind of like workflow of this thing is that like things return true. So we want to be like if bool int from bool, is there bool from int? As bool ret equals false, return error no cell or something. I think it's U32 because that's the safest default as it's U32 in many other languages. I don't think characters are ever U32, right? Like in how do I call it? Dude, my brain. In Windows, they use U16 strings. I've never seen U32 strings used, I feel like. But maybe I'm wrong. So then we want to, first let's just kind of start by doing exactly what we were doing before. So we're kind of going to go and we're just going to say, what's 80 times 24? More than fits in buff. More than fits in buff. So maybe we'll do like const final string. Rust is U32? No, I don't think so. I think Rust uses U8s. I'm pretty sure. Could be wrong though. This is gonna be an allocate U8s by num rows times num calls. Boom. Which means that here we need an allocator. Which means std heap general purpose allocator with no arguments. Defer GPA dinit. And then alloc is GPA allocator. And then here we can do this. Boom, 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 boom. And we go final string at call times num calls plus row. No, sorry, row times num calls plus call. We actually need this to be num calls plus 1 because we need an extra column for new line. Right, and then here we say final string this is equal to the cell dot oh, interesting. There can be multiple characters in a cell? How does that work? Surely not, right? Here he just says, oh, for like maybe for multi-wit, like multi-character things. So he dumps cell and increases call by that much. Oh, okay, maybe that's fine. Okay, no, that's fair. That's fair. So here we actually don't want to do a for loop here. We want to do var call is equal to 0 and do while call is less than or equal to num calls. Here we go. And then here, I guess we do something like For cell characters, no, it's for 0 cell cars width. Here we go. Call plus equals 1, which we could do all at once, but shut the fuck up. The optimizer will probably get it. Emoji probably, yeah, that seems pretty reasonable to me. That definitely sounds possible. And then we say final string this. No, but even then, the width here, like, wouldn't that be covered here? Maybe not, maybe not. Oh, I wonder if this is for Sixel. The fact that it's 6 here kind of makes me think that, but who knows? Who knows? Cars at I. Okay. And then what? Then here we say, probably at the beginning here, we say row at num calls. Sorry, it's a final string at row times num calls plus 1. Plus num calls is equal to a new line. We need to inject the new line every time. And then we have to be careful here because, again, num calls needs to be num calls plus 1. This is shit. I get it. I understand. We need abstractions, blah, blah, blah. But shut the fuck up. Okay, so then we don't do this, and we just use final string pointer and final string len here. And then hopefully we see like the same thing we saw before. That's what I'm hoping to see. Rect is unused. Okay, that's fair. Also, I know that Zig's STD uses U21 for code points. That's interesting. I didn't know that. I forgot to put a little squiggly bracket here. All right. And call needs to be set as a usize here. And while call is less than or equal to num calls, it should be less than num calls, I think. And row.row at 96. We int cast here, I guess. All right, what's next? He is mad because expected this, found that, because cell should have been one of these things at undefined. And then we should have passed him in by reference here. I think everything else probably is fine. I guess the cell usage now shouldn't be question marked. Like this, that goes away. And then please God, let it be done. I guess we'll just be like if ret equals 0 here. Expected U8, found U32. Yep, that's true. So can we truncate here? Oops, I didn't mean to do that. And let's run it. Okay. This is interesting. So first of all, we fucked something up big time. There's a lot to think about here. What is going on? So one, did we not so are the new lines not happening here or something when we do it this way? I mean, we should be seeing new lines no matter what from this. Unless somehow we're accidentally overwriting that. We could be from this. It's possible. We could do if call is greater than equal to num calls. break. But I don't think that's it, but it could be. So let's start there. So still no new lines. Very odd. Very odd. I'd be interested to look at like the actual bytes that are being seen here. So can we like stood debug print final string. Oopsies. Let's build first, then run it. Okay, so at the very least, we are sending the same broken shit. Can we print this as like, maybe we just hit the debugger, huh? Maybe we hit the debugger. Final. What's happening here? I pressed tab and my whole fucking debugger just kind of fell the fuck over. That's kind of fun. That's super fun. Can we kill it? Oopsies. Okay, key final string dot pointer. And can we look at this like for 100 characters or something? Oopsies, that's not what I wanted. I want to dereference this and look at the next 100 characters. So I see. It looks like they're using null character to represent an empty slot in the canvas. I wonder what this open 252 is. This escaped 252 is very strange. Very strange. Not at all what I expected. We might want to look at vterm screen get cell. So here they get the cell at this position. Then where does this come from? Where is this defined? Here we go. Screen buffer plus this thing. Okay. And does buffer have like a sentinel value at the beginning of the line or something? Look for 252. What's 252 in hex? Python 3 hex 252. FC, so let's look for that as well. We definitely see some 0xFCs in here. But this looks to be Unicode related. So probably not what we're looking for. Actually, I'm very confused. A little, very a little confused. I just want to double check. I looked this up before. Yeah, there's not really docs for this thing, which is fine. Which is fine. This is kind of what I signed up for. But I just want to know a little bit. Like, it'd be nice to see an example somewhere. I guess we were looking at examples before. We had unterm.c. And what did they do when they dump row? Right, they go from row here. They get a cell, then they dump the cell. And their dump cell, if all 7 attributes change, that means max each color should compute 5 entries, blah, blah, blah. Sure, and then they're like dumping this thing back out, sure. But like, for here, fill UTF-8. Whoa, what's that do? I don't know. But they iterate over here. Whoa, they set this to 0 and they dump it. Okay, that's weird. This is odd. This is definitely odd. But otherwise, I mean, it seems pretty straightforward to me that they're going 0, 0 as much as they can. Wait, it's 252. That's not like Zig's A, right? No, that's not like Zig's undefined memory sentinel value. I don't think it is. Right? We have like a, what is this, like a hex A? Can we do that? Can we do like int A? How do you fucking Python character code? Char or ord. Yeah, it's 97 is what I saw there. Or 61? Yeah, okay. Then not that. Okay, let's start by in our thing. We should try to rule out bugs in our code. So here, let's mem set final string to 0, 0. Start there. We will start there. Zig out. Terminal test. All right. Did we not print the thing? Am I stupid? I thought we did. Oh, no, we were using GDB. I forgot. Final. Oh, God, I did it again. I fucking tabbed out. Oh, my God. I don't know what it's doing, but this is kind of the reason I get pissed off by a lot of stuff. It's like, you can make like one small mistake and it just like fucks you. Okay, so can we dereference this thing and look at the first like, oh. So maybe we have like an off by one somewhere. First byte being 0 is like now instead of whatever it was before is like an interesting change of events. So here we have call 0. I did have the call plus equals 1 in the wrong spot. So can we run this again? Okay, that looks a lot better. That looks a lot better. We're back to where we expect it to be. Why? Do you guys notice? Do you guys see like that shadowing here? When I resize the window, it like has like shadows of the text behind it. It's pretty funny. But now we should be able to set colors of this according to the color in the thing. And so we might just get stupid here. We might. First of all, actually, before we do that, I changed my mind. I actually wanted to make sure that we're like final string pointer. Like, how does this... The fact that we have zeros kind of in this thing and it's still displaying correctly in QML seems like kind of a surprise. I guess it's because we're going through Q strings and Q strings aren't null terminated. So maybe that's fine. Maybe that's fine. Okay, here's what I'm going to do. We're going to make this a rich text thing. So this is going to be a std array list of U8s initialized with our wonderful allocator. Okay, we are going to pass in items here, and here. And what we are going to do is every time we see a character, I guess maybe we will push a new line at the end of every row instead of kind of just hard coding the position. Right, so we'll just do this. And then for this section, we are going to, every one of these guys, just put in a color code matching this thing. How's the general vibe around QML so far? Pretty enjoyable. We've done so little actual QML at this point that it's hard to say. Like, this is our program right now. But I'm sure that as we get more into it, we will have a better feel. Will N-curses work in this terminal? I believe so. I believe so. But we will see. So here I want to basically take the color from this thing as RGB. Can you do like rich text RGB? Is this something you can do? How do I set colors? Font color equals, can I do like QT RGB text? Somebody will have asked this. Q color, set color of text and background. Set style sheet, that's not really what I want. Set color, palette, set color in a painter, that's not really what I want. I want to just like embed it. Is there no like QT rich text color? How to create a bold red thing? Try using this. This is what I want. This is what I want. So for each chunk, we're literally just going to be like a final string. We're going to append like a span, right? And then in here, we're going to have like a, style, color. I guess here we need to escape the quotes, huh? Then we're going to have color is this. Okay, we're going to go RGB with 0 padded, right? And then what? Then what? We put the text in here. Yeah. Yep. So I guess we're actually going to write this as like a few separate blocks, because each of these columns is each of these characters is 32-bit, which is annoying. So here it's going to be like a final string dot append. Sorry, let me think. Std format buff print, I guess. Var span buff is going to be like, I don't know, 450 U8s. I don't really give a shit. We have this span buff. Span start is equal to this. Okay. Then I think we actually just append this. We're going to like final string append span start. Boom. And then we are also going to want to append something that looks like span at the end of this span. And then we're just going to have to iterate over each of the characters in between. I guess before this, we are going to need the RG and B, right? Which we know we can get somehow. We just don't know how exactly. So this is going to come from libvterm, vterm.h, surely. And there was like get color. They have a foreground color here, vterm color. Can we do like color to RGB? Oh, I see. So we have to see if it's index or if it's RGB. So I guess we convert color to RGB, then pull out the RGB. So it's like lib vterm color. Oh, I can just get out the thing as RGB? Is this true, or is this like assuming that the color is an RGB type already? Oh, this is creating one from an RGB. Ugh, fine. Vterm color. So we take the screen and use that to convert to RGB. For whatever reason, it needs a screen. I'm not going to ask. And this comes from wherever the fuck our color is. So span cell FG. That seems right to me. But is the cell a const thing? We got it out here. So we are fully game to do whatever the fuck we want to it, which is chill with me. Okay. So this returns void, which is fine by me. And so we're going to be like Cell foreground dot RGB dot red. Oh, sick. And is this a U8? Oh, hell yeah, dude. So now all we have to do is be like in here. Cell FG RGB dot. Boom, boom, boom. There we have our span start ready to go. And then all we have to do is iterate the characters for cell width. Right? I don't know what's going on. This is getting really unruly really quick. But that's okay. Final string, append the truncated thing. This, oh, we're already doing a cell width thing here. So this actually all has to come up like this. Bum, 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 bum. Dude, it's so bad. I'm actually struggling so hard to read this. But that's okay. That's okay. We will improve in the future. I think it looks like this now. So hopefully if we did everything right, we should see red text in our terminal output here in the QML side. He doesn't like this because we can't memset this thing to 0, which is totally reasonable. This is now an array. No field named R. Didn't I just test this? Didn't autocomplete tell me that it was R? Oh, it's red. Fine. Fuck off. You know? You know, just like let me. Why doesn't the language take my R and turn it into a red? Like, can't it read my mind and do what I want it to do? No feeling greed. Again, like, just figure it out, man. ChatGPT would figure it out. He wouldn't figure a lot of other stuff out. But, you know, he might have figured that one out. That's actually a kind of interesting project, maybe, is letting an LLM adjust your source code to fix very minor mistakes. An awful project, but it is kind of funny. Span start. Expected type U8 found U8. Oh, because it's append slice when we're appending slices. I don't know if you guys knew this, but a slice is a slice, and a car is a car. All right, let's see. We don't need GDB here. Fuck GDB. That's not what I was hoping for at all. Can we print the final string here? Final string. Like, we do need to compile the code if we want to run it as well. I don't know if you guys knew about that thing as well. There's a lot of subtleties in this world, and some of them are that you have to compile the code you want to run. It's crazy that I still don't know that. Okay, so surely this is a mistake. So this is kind of funny. We have each character has its own thing. Kind of funny. It's kind of interesting that the hello world. This is not what I was expecting either, for the record. EO, didn't I say prefix with an O2 in here? Didn't I say pad my shit? I thought I did, but I must just not know how to use Zig format strings. 0 pad number. I thought that like pad. Zig. Okay, we'll just ask the dumbass. Zig 0 pad hex character format. Dude, let's say you want a format. Shut the fuck up. Just give it. Okay, there's no way that's right. Right, there's no way. Oh, that could be it. That could be it. But I don't really believe him. He's a dumbass. That guy's a dumb piece of shit. Let's just look at the answer. Uh, padding. Fill is a single Unicode chord point. Okay, where's fill? Argument specifier colon fill alignment width dot precision. Oh, is it because I didn't have an alignment? Wait, yeah, so I filled 0 to the width of 2. Am I fucking stupid? If fill is required, one has to specify alignment as well. Ah. So I guess I just throw a little angle bracket in there. The dumbass is a dumbass again, you know? Okay, so where's that O2? So here we need this to be O angle 2. Let's at least fix one of the problems. Computers would be so much better without text. I mean, we wouldn't be able to interact with them very well. But yeah, better by some metric of better for sure. Okay. So here he gets to the hello world and then just has a bunch of fucking empty spans. And then we never get to the next line, which is interesting. I mean, I guess that technically this is like HTML, huh? So I wonder if we're supposed to use BRs if we get into that case. Can we, like, instead of doing anything here, can we just be like a const test is equal to like span style equals color, what is it? Color colon. And then the style is, yeah, style equals color colon OFOF or something. I don't know. FF0000. Let's make it red. Right? And we type like hello world in here. Why am I even doing this here? Let's just do this in the QML side. What the fuck am I doing? If we're gonna do a test like this, we might as well leverage the QML niceties. Set ft uses qt qml.js. There we go. So if we do like span hello and then like world. First, let's start here without any spans. So if we do this, okay, that's what I expected. Now here we do span. Now the world is kind of like adjacent, so probably that kicks it into like HTML mode. Sure, so our new lines have to be BRs, which makes sense. And then here, if I put like a color, style equals color, FF0000, then the hello becomes not red. So what the fuck is going on there? QML color rich text. Using the tag wrong, here's our way. Font. We can do that. We can try this, see what that does. Okay, nope. I guess we do have double angle brackets there. Okay, so that's a good sign. Font color, so we can kind of like yoink this thing over here and do that instead of span. So it was like this. Font color equals this. And then the span has to end with font now. And then this has to be append slice of BR, because we are now in, wait, are we? We're in HTML mode, right? I think we are if we have the angle bracketed shit in there. I guess here we want to go back to printing what we got from the other side. Okay, so now hello world is fully red, but now we're still seeing nothing else. So I wonder if we like expand this enough, if we like find it somewhere. I would also be interested in maybe not fucking having a bunch of empty spans. So how do we do that? How do we do that? Can we maybe breakpoint here? And can we look at final string? Dereference that thing, like 100 characters. Maybe we need final string dot pointer. No member name pointer. Okay, what is it then? Items pointer, fine. So can we look at like, you know, maybe like 500 of these things? Ugh, how do I like pointer plus 100, 50. And then let's go like plus 200, 400. So there are null bytes ending up in here, which probably is not helping. Probably not helping. So here we probably want to do something like if cell cars I is not equal to 0. That might help us a little bit, and then we probably want to do something like we probably want to only append the span if there was actually content to append in there as well. So here we probably want to be like we have the span start here, and maybe how do we do this? We want to like buffer the output. Span content. A little gross, but whatever. And then here we get the span content. And then here we say if span content dot items len is greater than 0, we append this thing. There we go. That feels about right. Feels about right. Feels about right. Okay, still no bueno. Still no bueno. But getting closer to bueno for sure. Where was our, was like P, breakpoint here, run, fuck, quit. We need a new breakpoint here now. Okay, can we look at final string items pointer? And we were dereferencing this from, you know, like plus 500 10 times or something. Maybe we want like 100 characters. And I guess we kind of want to look at the end of hello world because that's where it's kind of falling over. So we have LO RL LD. Then we have a BR here. Okay. So we should be getting close here. Hello world. H-E, whoa. D. Where's the BR? BR. And then LO something something. This is FO, FO, FO. So I guess maybe that color that's being printed is just very close to the background color. That's actually very possible here. So maybe if we in our QML terminal test zig, it could just be, sorry, terminal main QML. Can we just do like a QML set background color? Do we just have to throw this whole thing over like over a rect? Sure. This makes sense. Yeah, so we have a rectangle. Anchors, and we say, fill my fucking parent, please. Which I think means that this has to have like an ID of parent or something. Or is parent a special keyword? Looks like parent is a special keyword. Then they just say, we say color black. Let's see if that looks any better. Nice, baby. Okay, guys, don't say fill my parent. Okay. I do want to fill the parent, but not like that. Not the way you guys are thinking. That's gross. Okay. That's pretty cool. That's pretty cool. So now we can try to get like a little bit more advanced. Let's just test like a couple other cases. So can we like, what do you expect? This is like our job. What's like an easy way to test? I don't really want to like run top because we don't really have the capability of running like interactively right now. We only have like the ability to like snapshot something. It would be nice though to be able to like, I guess we have a bunch of like test cases in our mind already from when we worked on the what's it called? Something. Our terminal emulator before. So we could do something that's just like, you know what? I think I'm pretty confident that like the ANSI parsing is working correctly. If we can use color codes, then like everything else we can kind of expect will come for free to some extent. So I think it's probably fine as long as we have like a fixed size. And it's 4:30 and my back is killing me, so I think instead we call it there. This is not, a perfect implementation, but it's not so far off, right? Like you can totally see the path to get from here to something working. I think probably tomorrow we swing back in and we try to get this a little bit more in there, right? So we'll try to integrate with like the real debugger and try to hook up standard input as well. But this is like a really good start. Really good start. Is this your own terminal emulator? No, we are using libvterm to do most of the heavy lifting for us, and we're just going to be like, embedding this thing into our debugger because terminal, like output of programs, expects to be in a terminal, so we need to handle that. So I wanted to experiment with seeing how hard it would be to interact, embed a terminal with somebody having done the heavy lifting for me. So we're at pretty happy with the progress today. I think that we covered a lot here. Like we have like a QML app in Zig using libvterm. We had to patch libvterm a little bit because of the opaque pointers. We covered like QML/Qt rich text coloring and monospace font and stuff like that. So yeah, I think we're getting somewhere. We're getting somewhere. Happy with progress. So thank you guys for watching. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. Today, it is 4:30 Pacific time now, so anytime between 4 hours ago and now. If you're watching on YouTube, you're probably seeing the 2 to 4 segment, which is the main stream, but there's also like happy hour from like 12:30 to 2, where you can catch like kind of like less feature development and more like cleanup and supporting work. We focus more on vibes and hanging out, and if you want to check that out, those are archived in YouTube member VODs or Patreon, or you can catch them live on Twitch. Otherwise, is that all we have to plug? Like, subscribe, Twitch Prime, and thanks for watching, and I'll catch you guys in the next one. YouTube, goodbye, and Twitch, let's find someone to raid.